Hello and welcome to another video. If this was differentiation, you'd be thinking of the chain rule, product rule, or quotient rule. Because if you can't just do it applying the power rule, then you just have to find one of the other rules to help you. But in this case, there is no such thing as chain rule or quotient rule or product rule, even though you have a product. So there are other techniques in integration, and one of them, and the very first one you'll have to learn, is called U-Substitution. Now for U-Substitution, we're just saying, let's try and replace what looks complicated, the one we cannot reach. We can't reach this because it's locked under the square root sign. We can't reach this because it's raised to power 8. That's going to take a lot of foiling for you to be able to get a polynomial that long and then integrate. So let's just see a faster way. This one is locked into, this is locked into, this is a product. Okay? Remember, whenever you have a product, you're saying, can the derivative of one produce the other? If the derivative of one produces the other, then you say, okay, U-substitution is going to work. Well, in this case, it is obvious. Okay, because you can take just tan, the derivative of tan x is secant squared, so obviously that's what we're going to use. But here, the derivative of 2x plus 1 does not give us x. The derivative of 2x is just 2. The derivative of 3x plus 2 is 3, not x. So here, there's more algebra that's involved, and that's what you need to learn, because that's what throws people off. In fact, in this case, the derivative of x squared is 2x, but what we have here is even bigger than x squared. So what are you supposed to do? That's where the algebra works. So I'm going to take each of them and tell you what to do in each case when the power of the product is less, equal, or greater. Something you have to understand is that there's something called rough work on the side, or side work, or whatever you call it. Okay, that's what I'm going to do. I'm going to look at this and say, I'll write it in another color. I'm going to say, let U, remember what I said, be this thing that is trapped in here, 2x plus 1. So let's quickly find the differential. So du is going to be the derivative of this, which is going to be 2 dx. Okay? Remember, we usually would do du dx equals 2, but you use the dx to multiply both sides. That's how you get this, okay? So don't write this way, just go straight to this. Get the derivative of this and multiply it by dx. That way you don't have to write multiple lines. Okay. Now, once we're done with this, we can see that we don't want to have 2 because there's no 2 outside of the square root sign. So we want to rewrite this and say that 1/2 of du is going to be dx. You divide both sides by 2. So now dx here can be easily replaced. So see what I'm going to do. I'm going to replace dx. So I'm going to write my integral sign. I'm going to replace dx with half du. And remember, I already said u is 2x plus 1, so I'm going to write this as the square root of u. But there's still something we have not replaced. We haven't replaced x. Okay, now that I'm integrating with respect to, so this is all multiplication, okay? Maybe I should put this in parentheses, so I'm multiplying, I've replaced this. Now, we're integrating with respect to u now, so we cannot have x here. We have to change this x to something in terms of u. So go back to this original equation. If you don't want to write x anymore, and you want to write x in terms of u, how do you do that? Well, you just say, since u equals 2x plus 1, you can say this implies that u minus 1 over 2 is equal to x. You see that? I moved the 1 over here, that's u minus 1, and then divided by 2. And that's what you have. That's what you must do. So we're going to go here and say this is the same thing as u minus 1 over 2. Now watch this. This can be easily integrated. because what you have will be equal to the integral of, this can be u to the 1/2. So I'm just going to rewrite this so it's easy for us to multiply, to the 1/2. So u to the 1/2 times u is going to be u to the 3/2 minus u times this is going to be u to the 1/2 divided by, this 2 multiplied by 2 is going to be 4 du. Okay, it looks like we're done. So here we can easily have, I can move this 4 out as 1/4, and then I do the integral of u to the 3/2 minus u to the 1/2 du. So now you have du. Okay, and let's take the integral, that's 1/4, and then if you take the integral of this, it's going to be u to the, now how do you integrate? The fastest way is just to add, if this is a fraction, just say 2 plus 3, what do you get? 5 is the same thing as 3/2 plus 1, so 2 plus 3 is 5, that's 5/2 divided by 5/2, minus, this is u, do the same thing, 2 plus 1, that's 3/2 divided by 3/2, and plus c. Okay, the next is just algebra. Let me see what we can do here. Now, if you flip this, this is going to be 2/5, okay? So 2/5, there's going to be 2 here, so I can actually rewrite this as 2/5. So put 2 here, put 5 here, and get rid of this. The same thing, I'm going to put 2 here, flip it, put 2 here, and leave 3 behind, and get rid of this. You see that? That's a quick way. Now let's distribute this 1/4. This is going to be, oh, 2 is going to cancel this, so you have over 10. So here you have u to the 5/2 divided by 10. That's what you get on the left. Here you have 2 canceling this 2, you get 6. So you have minus u to the 3/2 divided by 6 plus c. Remember, as soon as you do your integration, you have to add the constant of integration to it. And basically that's your answer, as long as you go back and tell us what your u is, which is 2x plus 1. So I'm going to just replace this with 2x plus 1. Okay, so this is going to be equal to, let's write it this way, 2x plus 1 raised to power 5/2 divided by 10 minus 2x plus 1 raised to power 3/2 divided by 6. So this answer, plus c, is acceptable. Okay, sometimes your professor wants you to write this to look like this, so you might as well change this power to square root. Okay, so you can say that your answer is, I would like to write it this way, 1/10 of the square root of 2x plus 1 raised to power 5 minus 1/6 square root of 2x plus 1 raised to power 3. So whichever way you like this, plus c. Okay, whichever way you like this answer or this answer, and that's how that works. Let's go to the second one. There are 5 questions, we have a long way to go, but the next questions, we're not going to do a lot of explaining now that you see the concept. Okay, for the second question, it's the same thing. We're going to make this our u. So we're going to say, let's use the blue marker. So let's say chalk rather. Let u be equal to 3x plus 2. So that means that du will be 3 dx. So which means 1/3 of du is going to be dx. That's what we get here. So if that's the case, I can come here and replace this with 1/3 of du. Now I'm going to write this as 3x plus 2, but that's my u to the 8th, so that's times u to the 8th. And now I still need to replace this x from this expression, so I'm going to say that u minus 2 divided by 3 equals x. So I'm going to go here and say u minus 2. U minus 2 divided by 3. Okay, that's it. And now I need to distribute, because now what I have, I can move this. Wait, let's not distribute yet. Let's not move yet. Let's go this way. It's going to be the integral of u to the 9. This times this is u to the 9 minus 2u to the 8th divided by 3 times 1 over 3 du. So this times this is going to be 9, so I can take out 1 over 9 all together, and now inside I have u to the 9 minus u to the 8th du. Okay, now let's integrate. You see how easy this is? As long as you get this word cleaned up, you can do your u substitution. Okay, applying the power rule for integration, this is going to be u, so we're going to have u to the 10th over 10 minus u to the 9 over 9. Okay, plus c, which what I'm going to do is I'm going to distribute this 1 over 9 again, so I'm going to have u to the 10 over 9t minus u to the 9 over 9 times 9 is 81 plus c. What did we say u was again? It's 3x plus 2. So you can come here and say this is 3x plus 2 raised to power 10 over 90 minus 3x plus 2 raised to power 9 over 81 plus c. Nothing else I'm interested in. That's it. Should you factor, come on, whatever, I don't care. You could do that if you want to be beautiful. But I am just good. Okay, let's go to the next one. So you see how easy this is? Let's go to the next one. Okay, for this one, it's a little different because when you take the derivative, I'm just trying to see. Let's try and take the derivative first. Remember, you don't know what's going to happen until you first take the derivative of your u, and your u is that thing that is locked up. So let's say that let u be equal to x squared plus 1. So what is du? Du is 2x. Oh, 2x dx. Huh. So remember, you cannot bring this x here. X and du cannot go together. So the best you can do is to say that half du is x dx. Now let's go back to the problem. We don't want to replace dx because we can only replace x dx. Okay? Can we produce x dx from here? What if we remove one of these x's and push it to the side? So what if we rewrite this problem as the integral of x squared times x, but instead of writing the x here, we write it times x dx, and in the middle we'll still have our square root of x squared plus 1. This and this are still the same thing, and we have generated what we want to replace with half du. So I can replace this with 1/2 du. I still have my integral sign. Now this is my u, so I can write this as u to the 1/2. Square root of u is u to the 1/2, so I don't have to do multiple steps. And here I can replace x squared, write it in terms of u, because we already said that u is x squared plus 1. So from here we can easily see that u minus 1 is x squared. So here I can go and write u minus 1. Now I'm ready to integrate. Let's go. So if I multiply this by this, it's going to be the integral of u to the 3/2 minus u to the 1/2. Okay? And this 1/2 I can take all the way to the back here. Equals 1/2. And that's going to be du. So let's take the integral. That's 1/2 multiplied by u to the 5/2 over 5/2 minus u to the 3/2 over 3/2. Okay, plus c. I know some people would like to flip this immediately. I try not to, because when I've tried and done that, I made mistakes, and I don't like that because I just keep going, and sometimes I don't see the mistake until I'm done, and I go, why? Just take your time. Okay, so now I can flip each of these, and this is going to be 1/2 multiplied by, if I flip this, is going to be 2/5. Okay, 1/2 times 2/5 of, what is u again? It's x squared plus 1. So I'm just going to write, let me just write u so it's going to be u to the 5/2. Okay, minus, I do the same thing, 1/2 times the flipped version of this, so it's going to be 1/2 multiplied by 2/3 of u to the 3/2. Okay, so plus c. So our next line is going to be 1/5 of u to the 5th, and we already know what u to the 5th is. It's x squared plus 1, so this is going to be x squared plus 1. Raised to power 5/2 is the same thing as raised to power 5, but you take the square root of it, and if you are getting 1/5 here, you just divide by 5. Or you can just write 1/5, 1/5. Nice. Okay, minus. This is going to be 1/3. The same thing, you take the square root of x squared plus 1 and you raise it to power 3. And you add c to it, and boy, it's sweet. Okay, so just as we've done for the previous ones, we're going to take 5x plus 3 to be our u. So we say u is 5x plus 3. Let's say let. So that du is going to be 5 dx. So that 1/5 of du is going to be dx. So we're just going to replace dx with 1/5 du. That's it. That's all we need, because we don't have anything. So if you drop this down, this is going to be 1/5 du, 1/5 du. And we're going to rewrite this as 1 over cube root of u squared. Okay? Which is the same thing as the integral of u to the negative 2/3. Now, if you cannot change this to look like this, you shouldn't be doing integration. Okay, I just said that, but I'm serious about it. Okay, and what you have is 1/5 du. Okay? Now let's move 1/5 du. That's 1/5 of the integral of u to the negative 2/3 du. Okay, now if we take this integral, it's going to be 1/5 of, if you add 1 to this, now adding 1 to a negative exponent is basically saying 3 minus 2. Okay, 3 minus 2, because it's negative. Actually, that's the sequence. So if you had 2/3 positive, if this was a positive one, it's going to be 3 plus 2/3. If it is negative, when you integrate, it's going to be 3 minus 2/3. So this definitely is 1/5 of u to the 1/3 divided by 1/3 plus c. Okay? That's how it goes. So here what I have is going to be equal to, if I flip this, that's going to be 1/5 times the flipped version of this is 3/1, and then you have u to the 1/3 plus c, which is going to be equal to 3/5 cube root of u. What is the cube root of u? What's u? 5x plus 3. 5x plus 3 plus c. This is the answer we've been looking for. Okay, this number 5 is quite interesting because this is the general rule for trig. Once you see two trig functions multiplying each other, what you want to do is say, okay, I'm going to look at one of these functions and say, if I take the derivative of secant, will I get anything that contains tan? Well, if you recall, the derivative of secant x is actually secant x tan x. Okay, which means the derivative of secant x secant x will be, you can put the dx, so you can actually replace one secant x and one tan x. The problem is just that there's going to be a second secant x and there's going to be tan x, so it doesn't help you because it only gets rid of secant x tan x, but there's still a bunch of tan x's remaining. So There's no way unless you now write tan x to the fourth. No, it's not a good idea, okay? Don't go the way of secant, but go the way of tangent, okay? So if we take the derivative of tan x, d tan x is going to be secant squared x dx. You see that the method of going through tan x gets rid of every secant x, and you're done. So, while this is an option, it's only an option if the powers of tan x are minimal, like small, such that once you take your derivative, the tan x disappears, okay? If it was something like secant squared, x, tan x, then better. This is a good strategy for you to take. Whichever way you go will be correct, okay? But I'm just saying you can use the secant x option here because there'll still be some tan x that you can't get rid of, okay? So let's see our choice. Our choice will be let u be equal to tan of x. If u is equal to tan x, it means that du is equal to secant squared x dx, which I can generate here, secant squared x dx, okay? So I can rewrite this as tan to the fifth x secant squared x dx. It doesn't matter because multiplication is commutative, so it doesn't matter which one comes first, but now I have seen what I'm looking for, okay? So I'm going to replace this with just du. And I said u is tan x, that means this must be u to the fifth power. And then I can take the integral. That's it. This is easy, okay? If you take the integral of this, this is going to be u to the sixth power divided by 6 plus c. What? That's so easy. What was u? It's tan x. So this is tan x raised to the power 6 divided by 6 plus c. That's your answer. So 1 over 6 tan to the sixth x plus c. Practice, make up questions yourselves. If you think it's not working, maybe U-substitution doesn't work. Maybe you have to do trig substitution. Maybe you have to do integration by parts. Maybe you have to do integration by partial fraction decomposition. You just have to figure out what to do. Or maybe it's not something that you can integrate. By the way, not every function can be integrated by the elementary functions that we know. Okay. I just hope you got something from this video. If you did, give it a thumbs up, give it a share, give it a like. Make sure you're subscribed, and just do everything good about it. Leave a comment in the comment section. I'll see you in the next video. Don't stop learning, because those who stop learning have stopped living. Bye-bye.